what time, and we could see, I don't know what the unit of measure is, but we could see that the maximum height is here, whatever this time is. And another example would be if we're looking at the cost of an item is going to, well, it will be decreasing as the number of items increases, but then you reach a point where it will swing or change. So there will be a time where what is the minimum cost at what number of items is made. Okay, so we're interested in finding the vertex. And the quadratics that we've been looking at have all been centered where?
0.
At 0, 0. Okay, and and we're going to talk about this as the parent. Okay, I don't know about you. If you have a big line of family, you know, he has grandma and grandpa, and then all these different families and grandchildren, etc. Well, we're starting with the parents, and our parent is y is equal to ax squared. And right now we know, the only thing that we know is that the vertex, if this, the absolute value of this is greater than what, 0, it's going to be forward, and we know, upward I should say, and we know that that a variable controls the width, okay? And we know that if it's less than 0, it's going to be facing downward. We're good with that, right? Okay, so what I would like you to do, and we're going to learn, this is the goal of today's lesson, we're going to be learning about HK form, okay? We're going to be learning about HK form, and I will tell you what HK represents in a second, but just want to make sure that we know that any quadratic can be written in this form. F of x is equal to a. Okay, remember our a controls our opening. X minus h squared. Is that the same? We have our x squared here. Okay, and our plus k, where k is going to be our constant. Okay, so what I'd like you to do is I would like you to graph these 3 on your calculator.
Can you put that back up?
Yeah? Okay? So we're just looking, what we're going to be doing is we are going to be exploring quadratic equations in various forms, and that's why I was saying tomorrow's lesson is going to be an important lesson, because we're going to be looking more in depth at this h, x minus h squared. I think that would be a very good idea. This is important information.
How come the top one's the same as the bottom?
What's the difference between the two?
There's no h in the top.
That's right. So you're familiar, and that's what I'm saying. This is the parent. We know that in order for it to be a quadratic, it has to have an exponent to the second power, right? The second degree. And so this is a little bit different in that it is some quantity x minus h squared. And so what we're going to be doing is I'm going to teach you tomorrow how to write it in that form and why that form is very helpful. Okay? So today we're just going to focus on looking at what h and k mean and what they tell us. Okay? And then tomorrow I will teach you how to write it in that form. Okay? So does everybody have these entered into their y equals? Okay? Yes, no?
No.
Okay, I'll give you a second more. Kristen. Caitlin. Holy cow, now I'm never going to get it. It is Kristen. May I borrow your calculator? Okay. Yeah, now you can name tag. That's bad. 'Cause sometimes what happens is, okay.
That is exactly what I have.
Okay, that's what everybody should have. Okay. So if we look at that, it's 1/2 x squared was the parent. So what does that 1/2 do? It's controlling the opening. by adding the 4, so I had the same equation, but this time I added 4, this time I subtracted 4. Let's look at the graphs. And the graphs are the same except for what?
Y.
So what does adding a constant do to the graph? It shifts it up and down, exactly. Okay, so when I say K, you're gonna think, what? What are you gonna think?
Kangaroo.
Kangaroo, because what does a kangaroo do?
They jump.
They jump up and down. Okay, so K controls the up and down movement on your graph. Okay, please write that down.
What?
You need to know that. K represents the up and down movement. Why do you think I have a kangaroo up there for? I like kangaroos. Actually, I had fun going online, looking at that. Okay? Did it change the orientation of the quadratic? Was it reflected?
No.
Okay? It stayed put. It was right there. Did it change the opening?
No.
No. Okay? And it just stayed right there on the y-axis, and it moved it up and down.
Isn't it kind of like B though?
Sort of like B. Okay, sort of like B, because if I had the family y equals 2x, and then I added y equals 2x plus 3, you're right, it shifts it up 3 units, or it would shift it down. So it's kind of like the B. All right. Time check here. Holy cow. Okay, so let's see. All right. So why don't you try, let's do one problem together. So would you please graph y equals, let's go with the negative one. Let's do the B. Oh, so
Y equals what?
negative, it's a negative 2x squared. The next one is going to be y equals a negative 2x squared plus 3. And then the next one is y equals a negative 2x minus 2.
Negative 2x, not negative.
Negative 2x squared, sorry, minus 2. So the parent is the same in all of them, but the constant was plus 3, and this is minus 2.
Oh, makes a nice little bump.
Okay?
Like a team.
So does it make sense? Do I know that this is going to be flipped down? Okay, because I have a negative, and the only thing that has changed is what? The up and down. We're going to think of our little what? Kangaroo jumping right along. Okay, now,
Why are you saying that?
I'm sorry, what's the matter, Michael?
Nothing.
Okay, all right, are we ready to move on? Okay, let's try this. What I'd like you to do, where are we? Right here. Use your graphing calculator to graph. Now, look at what is squared. Have I just added a constant, or is this the squared term that is being manipulated a little bit? Remember, we said y is equal to ax squared, or y is equal to ax minus h squared. So this is my h term. Okay, so what I'd like you to do is let's plug in x plus 3 squared.
Wait, should we have the parentheses?
Yes, you need to make sure that you have parentheses because it's the whole thing that's being squared.
So,
Just that one
would the
though?
graph be different if you just, would it be the same if you just, like, did distributed, or, I mean, you squared, like, those, they look the same?
Where do I find?
Okay, you need to be really careful. Okay, that's a really good question. This x plus 3 squared means x plus 3 times x plus 3. And if I multiply this out, what do I have? 3x, this is plus 3x, and this is plus 3x plus 9. So don't just think not x squared plus 3 squared. You have to keep your parentheses. Because if I just did the distributed property, it's x squared plus 3 squared does not equal this. Okay? So what does this look like?
I'm not done.
Jessica, do you have it?
I do.
May I just use your calculator a second?
I'm calculating for my-
You colored it in, I don't want that. May I use yours? Thank you. Okay.
So we're gonna calculate it.
So does your calculator go like that?
Yep.
Okay, so what does H control?
Side, side,
Side to side.
Side, side.
Side to side. What do I have in my hand?
A hula hoop.
A hula hoop. So you're gonna remember that I will actually hula hoop for you. H is gonna move it which way?
Side to side.
Side by side.
Wow, it can also be just horizontal.
Or it could be horizontal, absolutely. Okay, that's no fun. Okay, you're absolutely
You're
right,
not
Laura.
fun, Laura.
Okay, so our H controls the movement on the horizontal, and the K is going to represent the up and down movement. Okay, all right, so let's do this problem. Thank you. Can you just give that to Renee?
Well, I cannot believe you.
Let's graph this problem and then see what we find out. So what is my H and what is my K here? And can you predict where the vertex is going to be by looking at this?